Hello guys, this will be a video about natural language processing and how social media, Google, search engines essentially process your text data. We're talking about natural language processing. We're basically referring to the processing of human language to the machine. Today we have many sources that generate data that is basically in a human readable language, but it's mostly unstructured, from WhatsApp to Instagram and Facebook. These data primarily are in a textual format. So if you want to process this data that is unstructured and from all these sources, then what you need to do is to use text-based processing algorithms. But what do these algorithms need to do to process this data? Well, they need to do text mining and natural language processing. Text mining and text analysis in general is a process of deriving meaningful information from natural language text. On the other hand, natural language processing, or NLP, is a part of computer science and artificial intelligence which deals with human languages. Essentially, what we're trying to do here is basically use text mining techniques to analyze text information and extract what we need to then incorporate it into natural language processing algorithms to process the data in general. This is why both of these techniques and algorithm go together. Now, what are the applications of NLP? Basically, where is NLP being used? Well, it's being used in sentimental analysis, basically understanding the opinion about someone or how someone feels. In chatbotting, that could be referred to Siri, when you're chatting with Siri and Siri replies to you in text, or where you chat to a client online and the client returns back a response. Speech recognition, basically understanding what you're saying, recognizing your voice and what you're trying to say. And in machine translation, a great example of this will be the Google Translator, basically translated from one language to another language. Other applications of NLP also include spell checking, keyword searching, information extraction, advertisement matching. Essentially everything you search to pretty much match you with advertisement material. Now, components of NLP drop into two categories: natural language understanding and natural language generation. The first component, natural language understanding, is all about mapping the structure of the language into information that we can understand. Then we process and analyze that information. The second component in NLP is natural language generation. Natural language generation is all about processing and creating sentences or grouping of sentences or words that represent natural language. The steps of natural language processing fall into 6 categories: tokenization, stemming, limitization, post-text, name entity recognition, and chunking. Let's talk about tokenization. Tokenization is the first step in NLP. What that means is that it basically separates the sentences into different tokens that represent that sentence so we can process them. An example would be to break the following sentence that you see in the screen into different tokens that basically represent each word. The second part is stemming. Stemming is basically retrieving the root of a word. As you can see from the example, we have a few words that you can see on the screen. Those words basically have one common word, one root word that they all derive from, and that is affect. So let's talk about limitization. Limitization is quite similar in explanation to stemming, but in this case, instead of just getting the root word, you basically get the morphological meaning of the root words. So in stemming, you attempt to cut the word to basically get it to a specific point. So from like swimming, swimmers to swim. But in limitization, you need to keep the meaning. So generally, in limitization, you would always get the output would always be a proper word, whereas in stemming, it would not really be a word. Sometimes it will be like part of a word. Also in limitization, as you can see from the example, the words gone, going, and went will be mapped into go. Now let's get into post-tags. Post-tags is another one of the steps that needs to take place, which is essentially breaking up the sentence in general into the grammatical meaning it has. Basically, if one word is a noun or pronoun or a verb or not. And to get a better idea, you can infer to the example you can see on your screen to understand what I'm talking about. Post-tagging is not perfect and you can have a lot of issues. If you refer to the example on the screen, you can see that Google something on the internet. Google can mean two different things in the grammatical sense, and in general in the meaning of the word. So how do you solve this problem? You solve this problem by name entity recognition. Name entity recognition is used to basically identify the context of sentences or words. Like if a word is a movie or a monetary value or an organization, quantities, person, location, etc. Let's take a look onto a sentence so you can get an idea of what I'm talking about. Let's talk about Google CEO Sundar Pichai introduced the new Pixel 3 at New York Central Mall. Now, this sentence can be broken into Google's as an organization, Sundar Pichai as the person, a location for the New York, and the organization again for the Central Mall. Finally, once you have completed all the previous steps, you can begin chunking. Chunking is basically taking individual pieces of information and grouping them into chunk of information. As you can see from the example, the Pink Panther has been allocated into one chunk, which is a noun phrase. It's separated by an adjective, a noun, and the, which basically gives the core meaning to the sentence. Now this will help into classifying what are the important parts of a sentence and understanding and getting an insight into what do they mean in the documents that we want to process. All of the previous steps that have been mentioned before are essentially what is taking place for natural language processing. Algorithms that are for natural language tokenization and processing basically do this stuff at the background. Thank you for listening, guys, and thank you for watching.